An El Nino pattern is expected to build this hurricane season, which will play a major role in terms of how many landfalls the United States will experience, as well as where exactly hurricanes are more likely to make landfall. If we were to take a look at what typically happens during an El Nino, we see that the sea surf temperatures around the equatorial Pacific are much warmer than average, which promotes a lot more lift in the atmosphere, which forces a lot of that air aloft in the upper levels of the atmosphere. And since there's so much air aloft in the upper levels, there's so much, the air pressure wants to spread out, since of course an area doesn't want to have a pressure an air pressure that's so high. So the higher air pressure in the upper levels will attempt to move to areas where the pressure is lower and where the air in the upper levels could sink, and that more likely happens in the Atlantic, where there's a lot more stinking and stable air during an El Nino pattern, where there's a lot more lift in this area. And since there's so much lift in the equatorial Pacific, there needs to be an equal amount of sinking air to pretty much balance out the amount of lift that's going on in the equatorial Pacific, and it more likely happens in the Atlantic. And since the air moves from a westerly to easterly direction, since it's moving from a higher air pressure in the upper levels to a lower air pressure in the upper levels, that creates stronger wind shear, because the winds in the upper levels are moving towards the direction that's opposite of the trade winds. So we see a lot more wind shear, and the winds in the upper levels will more likely steer storms a little bit further out to sea, or at least steer storms a lot further eastward than you'd expect in a typical hurricane season. So in areas such as the western Gulf of Mexico, you're less likely to experience hurricane landfalls, and we're less likely to experience hurricanes in general during an El Nino pattern. But we need to take a look at several factors before we can automatically say that this will be a below average hurricane season, not only when it comes to the amount of hurricane landfalls, but the amount of storms. But typically during an El Nino, we see storms move a lot further eastward, so that means that more of the East Coast would have more of an enhanced risk of hurricane landfalls than, let's say, the western Gulf of Mexico of the United States. So these two maps right here really goes to show how much of a significant difference the ENSO patterns make when it comes to the amount of storms that develop, as well as where exactly tropical cyclones make landfall. We see during a La Nina, there's much more storms that develop, much more hurricanes that develop compared to an El Nino. By the way, these are the La Nina and El Nino patterns over the last 30 years, and we see during a La Nina, far more hurricanes develop, and we see that far more hurricanes also move a lot further westward, because in the last 30 years, we've seen La Nina hurricanes more likely move into the western Gulf of Mexico, where we see tropical cyclones impact Texas. However, it's completely different when we take a look at an El Nino pattern, where the amount of hurricanes that develop in the western Gulf of Mexico, or at least the amount of hurricanes that move towards the western Gulf of Mexico, is almost non-existent, as majority of the storms, in fact, during an El Nino, move out to sea, or at least impact more of the eastern portions of the United States, where we see the eastern portion of the Gulf of Mexico experience some tropical cyclone landfalls, as well as portions of the southeast coast especially, and also in the northeast there is that possibility as well as a tropical cyclone to make landfall, despite the fact there's an El Nino. So based on this fact, we could assume that there's less likely going to be hurricane landfalls in the western Gulf of Mexico this hurricane season, because simply during an El Nino, the wind shear is just too strong, and the westerly winds in the upper levels are just too strong for tropical cyclones to be able to survive moving westward without being deterred by the strong westerly upper level winds. So we're more likely, if we were to see a hurricane landfall, it'll more likely be in the eastern portion of the United States for this hurricane season. Another thing we need to take a look at is forecasted height anomaly as we approach the main hurricane season months. And as you can see, there is expected to be a ridge of high pressure right over the main development region, and this could suppress tropical cyclone activity because there isn't enough lift right over the main development region for as many tropical cyclones to develop. Typically, during hurricane seasons where we see more hurricanes develop, we see a big ridge located just north of the main development region, which allows the main development region to have air pressure that's low enough along the surface for tropical cyclones to more likely develop. In the CFS models forecast, we see that by August, there should be a pretty big ridge that will somewhat suppress tropical cyclone activity. And moving into September, we see that for the most part there's going to be a strong amount of ridging this hurricane season in the main development region, which I think will suppress tropical cyclone activity just a little bit, since there's so much sinking air and not enough rising air in the lower levels of the atmosphere. So as a result, we should expect slightly less tropical cyclones because there's going to be a little bit too much ridging that will be induced by the warmer equatorial Pacific waters. But we have to also take a look at the sea surface temperature anomalies before we can jump to that conclusion, because they show a completely different story. Also, I want to point out that with ridging that's building like this, I'd say we're more likely to see storms move out to sea because we do have a weakness in ridging right in the middle of the Atlantic. So if we were to see a tropical cyclone move through the main developed region, we do have this small jet stream dip located along the east coast, and the westerly winds are a little bit further southward. So I'll say in a scenario like this, we're more likely to see storms move a little bit out to sea, or at least further eastward. So we'll see less tropical cyclone landfalls in a scenario like this. But also keep in mind that the CFS model is definitely far from certain. We've seen it a lot of times before, so take this with a grain of salt, but it's at least something to be aware of, that there could be that possibility there might be a little bit too much weakness in the northern Atlantic in terms of ridging for many tropical cyclones to move all the way westward. So make sure to pay close attention to that. When we take a look at sea surface temperature anomalies for this season, it shows a pretty different story, at least when it comes to how many tropical cyclones will develop and where exactly they'll develop, or where exactly they'll make landfall. So taking a look at sea surface temperature anomalies, we do see that much of the Atlantic is experiencing temperatures much warmer than average, pretty much majority of the northern Atlantic, especially in the main developed region. So that could cancel out any effects that a warmer equatorial Pacific would have on the Atlantic hurricane season if the sea surface temperatures are much warmer than average in the main development region, since typically during when the sea surface temperatures are much warmer than average, of course there's a lot more lift throughout the Atlantic, and since we're in a positive Atlantic multidecadal oscillation, we're more likely to experience tropical cyclones if the sea surface temperatures are warmer than average. So that could cancel out any possibility of an El Nino bringing stronger wind shear this summer. So I do think that as a result of the warmer than average sea surface temperatures, the hurricane season will fall more closer to average. And you're probably thinking, how will this affect the amount of landfalls that the United States will experience? Well, it's good to definitely keep in mind of how much warmer the sea surface temperatures are in certain areas, because let's say if the sea surface temperatures were much warmer than average where the Bermuda Azores High is typically located, then we'd see a weaker Bermuda Azores High, and as a result that could affect the exact area, or at least the exact trajectory of where tropical cyclones would move if the Bermuda Azores High is a little weaker. Because if it's a little weaker, we're more likely to see the Bermuda Azores High a lot smaller in terms of its reach, and we're more likely to see the westerly winds or plenty of troughs move along the east coast and steer this out to sea before it can make it to the United States. So right now, what we're seeing is that the sea surface temperatures are much warmer than average just north of the main development region. So I think that this could potentially weaken the Bermuda Azores High, and I think that will make it a little bit more likely that the Bermuda Azores High this summer will be a little bit weaker. So the chance that more storms move out to sea is certainly higher, thanks to the fact that the sea surface temperatures are much warmer than average to promote more lift and less sinking air associated with this Bermuda Ridge. So that's something to pay close attention to as well. There's going to be variations in the sea surface temperature anomalies over the next few months. We're going to need to pay attention to how this affects the Azores High, but I'll keep you guys updated over the next several days. But what's interesting is that sea surface temperatures are cooler than average in certain areas of the Gulf of Mexico and the Caribbean. So this would mean that there is a less likely chance that tropical cyclones will develop in those areas where the sea surface temperatures are cooler than average, and as a result, that would limit the amount of landfalls along the Gulf Coast, and a weaker Bermuda Azores High would limit the amount of landfalls along the United States in general. So we're going to need to definitely keep this in mind, but it is a trend that I've been seeing with the sea surface temperatures over the past several months. But this could make the hurricane season at least fall closer to average and below average thanks to the warmer than average sea surface temperatures. But since the location of the warmer than average sea surface temperatures are a little bit further northward, I think that will weaken the Bermuda Azores High to a point where we're going to see less landfalls overall in the United States this hurricane season. One good method in determining where exactly tropical cyclones will move this hurricane season is taking a look at analog years. And analog years are the years that are very similar to the year that we're experiencing this hurricane season. And the 2 years that seem the most similar to this year, taking a look at the past, are the 1957 hurricane season as well as the 1976 hurricane season. So taking a look at those two hurricane seasons, we see a very similar pattern. The reason why I say those years are similar to this year is because both of those hurricane seasons came off of years where we experienced 3 consecutive La Nina seasons, but now we're entering an El Nino, which is exactly what happened during the 1957 hurricane season as well as the 1976 hurricane season. So taking a look at those 2 years, we see a very interesting pattern when it comes to the amount of hurricane landfalls as well as the exact trajectory of tropical cyclones. So this is how the 1957 hurricane season looked like. So we see that there weren't many tropical cyclones that developed this hurricane season, of course, due to the fact that this was an El Nino year, so there's far more wind shear and stability over the northern Atlantic during an El Nino year. But also we have to keep in mind that this hurricane season occurred when the Atlantic multidecadal oscillation was in its negative phase, which means that more likely than not, the sea surface temperatures were much colder than average throughout the Atlantic. However, what's different this year is that we're in a positive Atlantic multidecadal oscillation. So I do believe we're going to see more tropical cyclones than what you see with the 1957 hurricane season, thanks to the fact that sea surface temperatures will more likely be warmer than average this season. But we see an interesting pattern with the 1957 hurricane season where we see a decent amount of storms that develop well out to sea of the United States, and we did see a decent amount of Gulf of Mexico tropical cyclones develop as well, and we did see one hurricane landfall right up along the Mississippi, or not the Mississippi River, but right up along the Louisiana-Texas border. But that's the only hurricane landfall we experienced this year, as I'd say more likely we see more storms move out to sea and develop somewhere in the open Atlantic rather than the Gulf of Mexico this hurricane season, since the wind shear, like I said, is a lot stronger and the upper level winds are a lot stronger from the west, which forces more of that tropical cyclone activity further eastward. So that's something to keep in mind. Taking a look at how the 1976 hurricane season looked like, we see that it's very similar to what the 1957 hurricane season looked like. However, of course, a lot more tropical cyclones in this season developed, but still, it's considered below average when it comes to the amount of tropical storms and hurricanes. But again, keep in mind the 1976 hurricane season occurred when the sea surface temperatures were much colder than average, thanks to a negative North Atlantic oscillation. That won't be the case in 2023 where we're in a positive North Atlantic multi-decadal oscillation. So, but we see that during an El Nino, coming off of 3 consecutive La Nina years for the season 1976, we see more tropical cyclones develop in the open Atlantic and mainly stay relegated as fish storms, not really affecting any land. We did see one tropical cyclone make landfall in the United States for this hurricane season, which was right in the middle of Long Island, and we did see a Category 1 hurricane come relatively close to the Northeast, but in the Gulf of Mexico, we see very empty for the most part when it comes to tropical cyclones. So I'll say more tropical cyclones this hurricane season will be relegated to the open Atlantic, just west of just east of the East Coast rather than the Gulf of Mexico. So keep that in mind if you're along the East Coast. There could be hurricanes that come closer for you guys than usual, but I'll say most of them will likely be stay out to sea, just like what typically happens during an El Nino pattern where the westerly winds force those tropical cyclones a little bit further eastward. So this was my hurricane season forecast that I made a few weeks ago, and you see that in the orange, I'm expecting around an average amount of tropical cyclone formation, but I do expect a decent fair share of tropical cyclones to move well to the east of the United States coast, but I wouldn't be surprised if we do see at least a couple of landfalls along the East Coast where the strong westerly upper level winds will more likely force tropical cyclones to stay a little bit further eastward than you'd expect. So keep that in mind along the East Coast, and I expect below average tropical cyclone formation thanks to the slightly cooler than average sea surf temperatures we're seeing in the Gulf of Mexico right now. And of course, the wind shear and the stability is a lot stronger closer to the equatorial Pacific. So I do expect more of the effects to be located right over the Gulf of Mexico as well as the Caribbean. So thanks to this, I do expect that the east coast of the United States will mainly experience at least an average likelihood of hurricane landfalls this hurricane season, and then below average for much of the western Gulf of Mexico. So I use this map to forecast the probability you will experience a hurricane landfall this hurricane season, and use my own assumptions based on how active or the typical tracks we see during a season very similar to this hurricane season, which is an El Nino pattern. And we do see that the areas that receive the most landfalls in any given year are North Carolina, southern Florida, as well as the southeastern portion of Louisiana, where right around North Carolina, you could peak out at receiving a hurricane once every 5 years, which is pretty often. And same goes for Florida, where you typically experience at least one hurricane landfall within a 50-mile radius once every 6 or 7 years. Same goes for southeastern Louisiana. And we do see that for the Northeast, the chance is a lot slimmer, where around New York City in any given year, you have a 5% chance of experiencing a hurricane landfall, and then it becomes, of course, very low, almost a once-in-a-lifetime opportunity, I'll say just north of Boston. But we do see that for most areas in the Southeast, there's around a 10 to 20% chance you experience a hurricane landfall in any given year, and then for the Northeast, it's around a 5% chance for the most part. But I change the percentages a little bit for this for hurricane forecast based on what I know. What typically happens with an El Nino pattern in a scenario like this. So this is my 2023 hurricane landfall outlook. So this is a probability of a hurricane making landfall within 50 miles from your location along the coast. So pretty much anywhere that's just north of Cape May, New Jersey, you should expect a 5% chance of a hurricane making landfall this hurricane season, which is around average for most of these areas along Northeast. I do expect that the El Nino pattern will reduce the amount of potential tropical cyclones developing, but this warmer than average sea surf temperatures will sure to balance it out to a point where I do expect an average at least an average probability when it comes to a hurricane making landfall in the northeast. And then taking a look for southward into the Delmarva Peninsula, you have anywhere between a 10 to 15% chance and a 20% chance along the North Carolina coast, which again is around average, your average probability of a hurricane making landfall. The El Nino and warmer than average Atlantic hurricane season temperatures should at least average it out, as well as the fact that typically storms move a little bit closer to the east coast during an El Nino than during a La Nina, where more storms develop in the Gulf of Mexico. So I'll say that will sort of even the conditions that suppress tropical cyclone activity during an El Nino. 15% chance for most of South Carolina as well as the coast of Georgia, which is around average. 10% chance for the northern coast of Florida, again average, and then 20% chance right around southern Florida, and then a large area of a 10% chance throughout the Gulf of Mexico, which is slightly below average, as I expect more tropical cyclones to move a little bit further eastward this hurricane season thanks to stronger westerly winds, and then a 5% chance pretty much extending anywhere just to the southwest of Houston, as it's very rare for tropical cyclones to move that far westward during an El Nino. So this is my probability forecast when it comes to a hurricane making landfall this hurricane season. If you want even more in detail forecast, make sure to comment down below your specific location close to the coast, and I'll make sure to give you guys a more in detail forecast regarding a probability a hurricane makes landfall within 50 miles from your location. So make sure to comment down below if you're interested. But thank you guys for watching, and I hope you guys have a great day.